So today we will discuss Codeforces round 1068 dip to problem C, Kanade's perfect multiples. So in this, we have given an array, initially given an array of size n and an integer k. The value k is the upper bound of all the elements given in the array. For example, 3, 2, 4, 6. In that, the max element is 6. So the value of k will be 6. And we have to find an array b, which will be an answer array. And for finding this, there are given two conditions. The first condition is for means all for the given array, all one of for each element, one of which divisors should be present in the array B. And the second condition is for all elements in the our answer array, where multiplier should be present in should be already present in the given array. This is the given array, and V is the answer array. And the time complexity we are given the size of any 2 into 10 power 5 means it can be max and log n. And yeah, so we discuss the first test case, that is 4 6. Okay, test case 1. Test case 1 is 4 6 3 2 4 6 3 2 4 6. So 4 is the size of the array and 6 the max element present here. So for this, the answer here given is 2 2 3. 2 is the size and 2 3 is the our answer array. So how we are getting 2 3? 2 3 is here the answer. So for 3, one of its divisor is present in our answer array, which is 3. For 2, the divisor will be 2, which is also present in answer array. For 4, the one of the divisor can be 2, which is present in the answer array. For 6, one of the divisor will be 2, which is present in your answer array. And for 6, both 2 and 3 is present. And this is the first condition. And the second condition is for 2, the multiplier will be 2. For 2, the multiplier will be 2 into 1 is equal to 2. 2 into 2 is equal to 4, and 2 into 3 is equal to 6. And 6 is the max key value. We have to go till 6 here only. And 2 is present in the current array, which is here. 4 is also present in the current array. 6 is also present in the same. In a similar fashion, if we go for 3, 3 into 1, this is condition 2. 3 into 2, which is max 6. We have to go till 6 only. 3 is also present in our current array, which is here. And 6 is also present in our current array. So both the conditions are satisfied. So this is our correct answer here. 2 and 3. Now, if we go some other test case, example test case 3, 3 6 3 6 and 2 3 6 2 3 6. Here the size of the array is 3 and the max element is 6. That was 6. So for 2, if we check the first condition, so the answer should be, so 2 should be there, and for so that it can properly divide. And for 3, 3 should also be there. But if we check multiplier of 2, multiplier of 2 will be something like 2 1 is 2, 2 2 is 4, 2 3 is 6. We have to go to 6 only, since max value is 6. But 4 is not present. 4 is not present in this array, in the given array. So in that case, maybe we have to return -1. So this is the impossible case, since 4 is not present in the current array. Now, if we talk about the solution approach, means solution If we go through this, the first test case one, test case one was 3 to 4 6. Okay, 3 2 4 6. So we have to include the first element. We have to go one by one. So if we take the smallest element from this, so the smallest element will be this one, and if we include it in our answer array, we can include it, or should we take some smaller multiplier? If we take some smaller divisor of this, the smaller divisor is 1, but 1 is not 1 into 1 is equal to 1, which is not present in this current in the current array, so we cannot take this one. So the conclusion here is we have to take the smallest element first. And similarly we have to proceed. So first of all we will take the smallest element is 3 2 4 6. So for the answer array we will take first of all the smallest element 2, and for if we go with for 3 then we will take 3. This is our answer array. And similarly if we go for 4, since we had already taken for 4 the answer can be 2 and 4. Since for 4 we had already taken 2 can be divided. So we had already included that, we have do not have to go for this again. And similarly for 6 we had already included 2, which is a divisor. And we can conclude from 2 also, or conclude from 3 also, since 3 is also 6 divisor. So we do not have to include it twice. So this will be our answer array in this case. But taking the smallest, so the approach is taking the smallest element first, and do not approach will be like this. Take the smallest element, take the smallest unfinished element. The smallest and unfinished. Unfinished, I am saying, since we do not, so that we should not repeat it further. And in the similar fashion, we can solve it. And if we go for the code, we may move on to code now. So this is the approach. Take the First take the smallest unfinished element and check all its multiplier. And in the case of missing, if any of the multiples of x is missing, in that case that will be the impossible case. Otherwise, remove means the after taking the smallest element, remove it and proceed further. Means repeat the process. So we are moving on, including the step I will include the header first of all. Then our main function started here. So for fast input output processing, we may include this also. Okay. Now moving to the test cases. We can create one function for this. And since it is an integer, so we may return 0. Okay. Now we will write the solve function. So first of all, we are given okay n and k and the array. We are we do not have to include the duplicates. We do not have to consider duplicates. The test case is given. I can show you. Okay, in the test case not present. 3246 for 3246. 3246. If six, one more six is there, there no need to go further since two had already solved for four or six, and for this also it has already been solved. So we do not have to consider duplicate. In that case, we may take something set so that it does not contain any duplicate. We will store the distinct element there only. We will also try to remove the once we are taking the smallest element, we will try to remove elements from this. And for checking whether the element is present or not, we may take my okay. Now processing the array. Also put it in the map also. Okay. We should create a answer as vector v or vector answer. We call it an answer to store the answer. Now we have to process each element. Okay, for each element we have to process. So for processing, what we may go for complete array or yeah we can write something like this. Until the set is not empty, we will process. We will do our operations. So the operation we will first take the smallest element. Okay, for taking the smallest element in C++, the set is ordered. Means the elements by default the elements present in the set is ordered. So we may take the first element, which will give the smallest element, and we can put it in our answer. Now we have taken the first element. Now we do not need it in the set since another one will be shortest for the next time. So we will erase it from the set and okay, I think this should work. Now we according to the second condition we also have to check means its multiples should be present in the current array. Otherwise, our answer is not means in that case it is not possible. So we will iterate and check that for the current one whether it is present or not. I am getting multiples. The first element I had taken this has to I am taking its multiple. Multiple I am adding current plus that element multiple times to get its multiple. Okay. And if it is not present, in that case our answer, since the multiple is not present, then the condition, second condition will be false, and in that case we are not getting any satisfactory answer like this. In the third test case, so we will return -1 and return. Otherwise, if this that doesn't happen, in that case we move further and we take for the current one, and we will, since we are not taking the elements multiple times, so we will also delete it multiple. For example, we had done this here in the case of 3246. In the case of 3246, we had only considered for, we had seen only for 2 and 3 and 2, and we had not go for 4 6. Since it's multiple of 4 is multiple of 2 and 6 is also multiple of 2, so we are not taking this, so we have to remove this also. If we had considered this, then we do not have to consider this whole thing. So I am going to remove the multiples. Okay, multiples now erased, I think. Okay, now now our answer contain the smallest possible, the required set. So you have to return in the format of its size and its value. Okay, size, okay, and its value will be something like, after in there, and there will break up, recognize blended. Okay, I think this should work. One more time, we should test. Okay, some syntax error is there. Okay, I should submit this. Not submitted. So if we talk about this time complexity, so here, okay, so mm, so here the time complexity will be for loop will be log uh, n, and for the insertion operation will also take some time. So if insertion operation is taking time, then in that take n log n will be here. Okay, log n and n log n, and here, okay, this is a bit tricky. Okay, this will take approximately k by t. Since for example, for 100, if n is equal to, if n is not, if n is equal to 2 and k is 100, in that case the multiples will be like 2 4 6, means 50 times. 50 times. So 50 times will be 100 divided by 2 is equal to 50. Similarly, if n is equal to 20 and k is equal to 100, in, in this case 20, 40 means 100 means this will be total 5 times. 5 times 20, 40, 60, 80, 100, which will be 100 divided by 100 divided by 20, which is 5. So here in this case it will be k by t. P by t this will be that, and which will process for each element, which will go for the complete array, and the age will also take some time. So it will be log n. It is that is log n. So the final time complexity will be write it time complexity. The final will be n log n discussed earlier, plus for this operation we synchronous some n. This was n or this was n. Okay, k by n. So it will be k, and since for each we are taking, and k by t sum will be there because each element was na, yeah. So k by t and it is also taken, so log n. This will be the time complexity for the complete. We are not taking any extra space. Space complexity will be n only. So that's all. Thank you.